Students, so today we'll be solving chemistry MCQs from this mock. I'll be solving them and then I will be explaining the correct answer and I will be explaining why the other options are wrong. So for the first one, we have which sample contains mole of atoms. So you have to read the question really carefully. They ask for atoms, not molecules. So you must make sure that you read the question carefully. Now they have given us grams, like all the quantities are in grams. So you must recall the formula moles is equal to mass over molar mass. Okay, so the mass is in chemistry we always use grams whenever we are dealing with calculations. Uh, in moles we always use grams. In physics we use kgs most of the times, and the SI unit for mass is kgs, but in chemistry we will use grams. Okay, and molar mass, the unit is gram per mole. Okay, and this N stands for mole, so you must memorize this equation. So for the first one, 2 grams, the molar mass for H2O, H2O is, you should know it will be 18. So but so 2 into 1 is the AMU, or the atomic mass of hydrogen, plus, and we have to add that of oxygen as well, so it will be 18 gram per mole. Okay, this is the molar mass of H2O. So you will add the molar mass of hydrogen and then oxygen, but as we have two hydrogens, so we have to multiply it by 2. So I hope you get it. So divide by 18 gram per mole, you get 1 over 9, 1 over 9 moles. So you get 1 over 9 moles. But remember, these are 1 over 9 moles of H2O molecules. But as you know that they asked us for atoms, and one molecule of H2O we have three atoms, 2 atoms of hydrogen and 1 atom of oxygen. So we must multiply 1 over 9 with 3, and the answer we get is 1 over 3 moles of atoms. Okay, of atoms in 2 gram of H2. And the question says that which contains 1 mole of atoms, and here we have 1 by 3, so of course this one would be wrong. Then we do the same thing for the second one, 18 gram. We calculate it here, 18 gram per mole, right? 18 gram per mole. You divide, you get 1 mole. Now 1 mole of H2O molecules. Again, we have to go from molecules to atoms. So there are 3 atoms in H2O. So it will be 1 into 3. So it will be 3 moles of atoms. Okay, which is again wrong because it's not 1. So again wrong. Then we do the C part. So let me just erase this one. So yeah, let's do the C part now. 32 grams of oxygen. Oxygen, the molar mass, or you can say the atomic mass, 16 gram per mole. But we have O2, so we have to multiply it by 2, which is 32 gram per mole. Okay, so 32 gram per mole, which is 1 mole, 1 mole of O2, O2, 1 mole of O2 molecule. But again, we have to go from molecule to atoms. Now there are 2 atoms in 1 molecule of oxygen, so it will be 1 into 2, so 2 atoms. Okay, 2 atoms of oxygen. Okay, so two moles, 2 moles of atoms of oxygen. Okay, so this one is also wrong. So the by elimination we can get that D is correct, but to show why D is correct, we can do the same thing with D as well. So the molar mass of sodium, molar mass of Na is 23 gram per mole. And using the same formula, N is equal to number of moles is equal to 23 gram per mole. 23 gram divided by 23 gram per mole is equal to 1 mole. Now, sodium is a metal and it is already in uh, atomic form. It's not a molecule. So we would say 1 mole of atoms of Na. So this would be the correct answer. Uh, okay, so one more thing. For sodium, like usually in IMAT, they will give you the molar mass or the atomic mass they will give you. However, for some of the elements, it's good if you remember for carbon, for hydrogen, for nitrogen and oxygen. So this one is 12, this one is 1, this one is 14, this one is 16. So, but most of the times they give you the molar mass, so you don't have to memorize the molar mass for each and every element in the periodic table. So moving to the next question, hybridization of each carbon atom in benzene ring is. So first of all, you should know the structure of benzene ring. So you can either draw it like this, yeah, like this, with the ring. So benzene is C6H6, and it has a delocalized pi system of electrons. Pi system of electrons. Okay, so you can either draw it like this or either like this. Okay, either like this with alternating single and double bonds. So one double bond here, one single bond here, then one double bond here, one single bond and one double bond. Now you just draw the rest of the structure. So one carbon is here, one hydrogen 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 here. Actually, this I think this was one of the question in like IMAT past papers. So the answer here is SP. SP is not the answer. SP3 is also not the answer. The answer is SP2. So SP is in linear molecules, linear. For example, we have CO2, okay? CO2. This is a linear molecule with 180-degree. Now here the hybridization is sp. The hybridization of carbon is sp. Okay. So for this one you just have to memorize. Okay. Whenever there is a linear molecule 180-degree, the hybridization is sp. Okay, because carbon is bonded with two other elements. Okay. Here, if you look at one carbon, it is bonded to hydrogen and two other carbons. Okay, so in total it is bonded to 1, 2 and 3 atoms. Okay, 1, 2 and 3 atoms. Here only 2. So in linear it is sp, and in this is a trigonal planar structure, and the angle is approximately 120-degree. So these things you have to learn, you have to memorize them. There's no other way around, there's no other trick, you have to just memorize them. Okay, so this would be the answer. C is wrong as well, because let me just erase this so it's easy for you to understand. So C is wrong as well, because sp3 is, for example, if I draw this structure, methane. Okay, so the carbon is bonded with four different atoms, four different atoms, hydrogens. So here we would have sp3 hybridization, and the structure would be tetrahedral, and the angle is approximately 109.5-degree. Yeah, approximately. Sometimes 109, sometimes 109.5. Some book says 109.5, so some 109. So both are acceptable. So here sp3. So this one is also wrong. So the only correct answer we have here is sp2. Okay. Moving forward. So okay. So this one is also wrong, because carbon does not have uh, any hybridization like this. Like it does not involve the d orbital. So this one is wrong. So carbon can only have these three hybridization, and in benzene ring, the correct answer is this one, sp2. Okay. So how many moles of O2 are required to completely combust 2 moles of C2H6? Now C2H6, an organic compound, a hydrocarbon, and the name of this is ethane. Okay, so first of all, do this question, you have to make an equation completely combust. So complete, so they are like complete combustion and incomplete combustion. Complete combustion is in excess of oxygen, and the products are CO2 and H2. Okay, and in incomplete combustion, the it's in the oxygen is limiting, and the products can sometimes be carbon, sometimes carbon monoxide, so they will specify what are the products. Okay, but here in complete combustion we always get this. Okay? So plus O2 gives CO2 plus H2. First of all, you need to balance this equation. So to balance, just write 2 here and 6, so and 3 here. Let's count if it's balanced right now. So 2 carbons, okay, and then 6 hydrogens, carbon hydrogens balanced. Okay, so we have 2 oxygens here, 4 oxygens here, and 7. So 7 oxygens here. We can just write, uh, if there are 7 oxygens here, we can just write 7 by 2, but it's better to write in whole numbers, so we just multiply everything by 2, so it becomes C2H6 plus 7O2 plus 4CO2 plus 6H2O. Okay, so let's count again. 2 into 2, 4. 4 carbons here, carbons are okay. 12 hydrogens, 12 hydrogens, hydrogens are also okay. 14 oxygens, so 4 into 2, 8. 8 plus 6, 14. So 14 oxygens. This is the balanced equation. How many moles of O2 are required to complete it? So how many moles? Okay, so complete equal 2 moles. So 2 moles of C2H6. Now, how many moles of oxygen? So look at this, C2H6. We have 2 moles of C2H6 and O2. Okay. Now looking at the equation, the mole ratio is 2 ratio 7. 2 ratio 7. Okay. Now they gave us 2 moles of C2H6. So we have 2 moles of C2H6, and we need to find the moles of O2. O2 required to completely combust 2 moles of H2H6. So we will just write what this is the method I use. So you just write ratio the ratio according to balanced equation, 2 ratio 7, and then what you do is that you write the given amount, so the given amount is 2 moles here, and then you just write x here, and you just cross multiply. So 2x is equal to 7 to 2, which is 14. 2x is equal to 14, and then you divide by 2, you get x is equal to 7. So we need 7 moles of O2 oxygen to completely combust 2 moles of C2H6. So the answer here is D. Okay, so here you just need to do the calculation, balance the equation, then find the number of moles. So all the other options are wrong. So which particle determines the chemical properties of an element? So always remember, this is the valence electrons. Neutrons, they are only like in isotopes, and it does not concern the chemical properties, because isotopes uh, have the same chemical properties but different physical properties, like density. They have different physical properties but same chemical properties, because chemical properties and reactivity and bonding, these are always dependent on the valence electron. So D would be the correct answer for this one. Which bond has the greatest ionic character? So to solve this question, we need to uh, so ionic character. So we need to find the compound, like the compound in which the elements have the greatest electronegativity difference. So of course, we won't be provided with a periodic table in the exam, but you should still have a rough idea. Uh, actually, you don't even need to consider the electronegativity difference here because it's really easy. CH bond is non-polar. Okay, it's just a fact. Okay, OH bond, it is polar, but it's not ionic. So not this one, not this one. And we know that NaCl is an ionic compound. So of course it would have the greatest ionic character. NH bond, again, it is polar covalent. Okay, this one is ionic bond. So this one would be the answer. The C would be the answer. A reaction has delta G less than zero, but proceeds extremely slow at room temperature. So what does this mean? Whenever delta G is less than zero, it means that it is spontaneous reaction. Spontaneous reaction. Okay, it is a feasible reaction. Okay, but still, even if it is a spontaneous reaction, it is occurring at an extremely slow rate at room temperature. The most reasonable explanation is the reaction is exothermic. No, this is not the correct answer. Okay, reaction is reversible. No, this is not the correct answer. Activation energy, yes, this is the correct answer. This is the most reasonable explanation for this question because whenever you have high activation energy is the energy needed to start a reaction. Okay, whenever you have high, so if I draw a energy profile diagram here, so for example, this is the energy profile diagram. Okay, so this is the progress, and this is the energy value or enthalpy change. Okay, enthalpy change. So here, what type of reaction is this? So here we can see that these on the left hand side we have the reactants and here we have the products. Okay, so reactants energy is more than the products. Okay, so this is, so if you look at this, products have less energy than reactants, so it means that the reactants have lost energy to the environment, and this kind of reaction is called exothermic. So the activation energy is from this point to this point, from reactants to the peak of the curve. This is the activation energy. So if you have more activation energy, then the reaction will occur at a slow rate because it will need more energy to start the reaction. So the answer would be this. So a gas initially at 2 atm and 300 Kelvin is 600 at constant volume. The final pressure is, okay, so for this one, what you can use is just simple. So this one is constant volume and this one is talking about maybe so PV is equal to nRT. You can do it like this. So here you can say this one is constant and these two are also constant. Okay, so the only things changing are pressure and temperature. Okay, so what you can do is that you can bring P1 divided by T1 is equal to P2 divided by T2. Okay, so because these things are constant, these are constant, so you can just write it like this: pressure 1 divided by temperature 1 divided by pressure 2 divided by temperature 2. So these are the initial conditions and these are the final condition. Pressure 1 is 2 atm, temperature 1 is 300 Kelvin. Always remember to if they have given in the Celsius degree, first convert into Kelvin and then enter that value here. But in this question, they have already given in Kelvin, so no need to convert. But I'm just telling you that if they have given you in Celsius, then convert it into Kelvin. Okay, so then final pressure, instead, so P2 final pressure 600. Just cross multiply. 600, 2 into 600 is equal to 300 into P2. So this is 1200 is equal to 300 P2. P2 will be 1200 divided by 300. Okay, so this will be 4 atm. So the answer will be D. Which solution has the highest pH? Okay, so first this is the answer, because this is a really straightforward question. Pure water has a pH of 7. We all know this. HCl is acidic. So acidic. So if I draw the pH scale here, yeah. So from here to here, it will be acidic, and from here to here, it will be basic. So higher pH means that it is more basic. Okay. Lower pH, it is acidic. Okay. So this one is of course wrong, because even if we try to calculate it using the formula, we would find that, okay, so you can try calculating it with the formula. pH is equal to minus log of 10 concentration of H plus ions. Now HCl is a strong acid, so it will dissociate completely. So it will form 0.01 mole concentration of H plus ions, which we can write as 10 raised to power minus 2. Okay, so minus log 10 and then 10 raised to power minus 2. In maths, you will learn about logarithm logs. So this will just become minus 2 and log 10 of 10. This becomes plus positive, and log 10 of 10 is 1. So this is just 2, pH 2. So the pH is 2 here. And this one, you can also solve this. Now this one is NH4Cl. This one is a salt. So to calculate to know, guess the pH of a salt, we need to do salt hydrolysis. Okay, so NH4Cl. So NH4Cl. We need to find an acid from which we can get NH4, and uh, we need to find a base or an acid from which we can get NH4, and an acid or a base from which we can get Cl. So from HCl we get Cl, right? And from NH3 we get NH4. So when they react, we get NH4Cl. So a base NH3 and an acid HCl, when they react, they will form NH4Cl, this salt. Now NH3 is a weak base, okay, and HCl is a strong acid. So this salt NH4Cl, because HCl is a strong acid and NH3 is a weak base, it means that this salt will be acidic salt. So this one is also wrong, because it will be an acidic salt, and the answer is this one, NaOH, because we all know that uh, it is a base, a strong base, NaOH. So for this one, it was completely straightforward. Okay, so adding a common ion to a saturated solution will, so this is common ion effect, is called as common ion effect, ion effect. For example, if you have CaCl2, okay, this ionic compound does not dissolve completely in water, so it will form an equilibrium. So CaC2 plus 2Cl minus. Okay, 2Cl, just 2Cl. Okay, so 2Cl aqueous. So when we dissolve it in water. Okay, so if adding a common ion, for example, if we add common ion, we can either add Ca2 plus or Cl minus chloride ion. If we add chloride ion, now we know that uh, if we add this, the concentration of this will increase. Okay, the concentration will increase. Now, Lee Chatellier's principle says that whatever you do to a reversible reaction, in a reversible reaction, whatever you do, the reaction will do the opposite of what you do. So, for example, if we increase the concentration of Cl minus, chloride minus ions, so the reaction will try to decrease its concentration. And how it will decrease its concentration is by favoring the left hand side. So it will form more of this CaCl2, and the solubility will decrease. So this is the answer B. Which change increases reaction rate without changing equilibrium position? So this is really easy, like adding catalyst, because uh, what does a catalyst do? Lowers EA. EA is activation energy, and in a reversible reaction, for example, uh, you can consider this one. Okay, if we add a catalyst, uh, it will increase the speed of the forward and the backward reaction, both of them. Okay, so and it will help us to get the equilibrium faster. So that's why adding catalyst will only increase the reaction rate, and there will be no effect on the yield. Okay, only the reaction rate will be changed. In a galvanic cell, electrons from anode to cathode. So anode is the place where oxidation takes place. Oxidation is the loss of electrons, where electrons are lost, and these electrons then travel to the cathode. Okay, where electrons are gained. Electrons are gained. You can remember oil rig for this. Oxidation is loss of electrons. Rig, reduction is gain of electrons. So the other option is wrong because this is the opposite. Through the saltbridge, no, this is also wrong because through saltbridge ions flow. Ions flow, not electrons. So this is wrong. Only when circuit is open. So this is also wrong because in a galvanic cell, the circuit is closed. So this is the answer. B is the answer. Which compound can show optical isomerism? So to show optical isomerism, carbon should be sp3 hybridized, and it should be uh, connected to four different groups. Four different groups. Okay. Okay. First of all is methane, CH4. Yes, it is sp3 hybridized, but it is not fulfilling the second condition. Okay, this carbon has four groups which are the same: hydrogen, 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 hydrogen. So this cannot show optical isomerism, because to show optical isomerism, the term we call is that we should have a chiral carbon. Chiral carbon should be sp3 hybridized, and it should have four different groups. Okay, so it cannot be. Now moving to the second option, we have C2H6. So this is ethane, C2H6. Again, if you look at this carbon, it is connected to hydrogen here, hydrogen here, hydrogen here. Of course, this group is different, but then these three are the same. So of course, this cannot be the answer again. Moving to the next one. So CH3, we draw CH3. CH3, C, H, OH, and then CH3 again. Okay, CH3 again. Looking at this carbon, let's see. No, this is not chiral because it has hydrogen here, 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 which are the same. No, not chiral. This one has hydrogen here, yes, which is different than OH here, different. But if we look here, it has CH3 group here and CH3 group here. So these two are the same. So these cannot be a chiral carbon, no, because these two groups are the same. Now let's look at the last option. So the last option, we have CH3, C, H, OH, C, OH. Now let's look at this one first. This one. Is it chiral? No. Because as I told you that it should be sp3 hybridized. Whenever we have a double bond, it's not sp3 hybridized, it will be sp2 hybridized. So this cannot be a chiral carbon. Look at this one now. This one has hydrogen here, OH group, hydroxyl group here, CH3 methyl group here, and then carboxylic group here, carboxylic acid group here, okay, carboxyl group. So it has four different groups attached. It is sp3 hybridized, so this one is chiral carbon, and this one can show optical isomerism. So to show optical isomerism, we should have at least one chiral carbon. A buffer solution resists changes in pH, and so this is the definition of a function of buffer solution. What does it do? It resists changes in pH when small amounts of acid or bases are added. So this is the only correct answer. This one is wrong. This one is also wrong. So this one is like testing your theory. Okay, so a reaction proceeds with low yield despite delta G uh, Gibbs free energy is less than zero. The most likely reason is so low yield, again low yield. Now here it says low yield, okay, and the difference between this question and this question is because here they are saying asking about reaction rate, okay, reaction rate, and the most reasonable explanation was activation energy, because activation energy affects reaction rate. However, here they are asking about low yield, okay. The reaction is spontaneous. Yes, we know that the reaction is spontaneous, but it does not explain why it proceeds with low yield, so this cannot be the answer. It's endothermic. No, this one is does not also explain the answer. Reaction is reversible. Yes, this one does, because imagine if a reaction is reversible, it can be spontaneous, but still if it is reversible, like we get the forward and backward reaction, then there will be low yield of the products. For example, in when we talk about production of ammonia, NH3, this is a reversible reaction, okay. So 2 and 3 here, okay. So this reaction, although if uh, it has delta G is equal to less than 0, but still if it is reversible, then we will get low yield of this one, NH3, because uh, at the same time this will go here like this will form N2 plus H2. At the same time, N2 and H2 are forming ammonia. Okay, so the last MCQ now. So N2, so this is the same equation, same. So N2 plus 3H2 to NH3, and this is enthalpy less than 0. So it means that it is exothermic. Exothermic means that energy exits. Okay, energy is exits and is given to the surroundings. Okay, so here, how which change will increase the equilibrium concentration of NH3 without changing the equilibrium constant? Now, equilibrium constant is Kc. Okay, now Kc is written like this: NH3, the concentration of NH3. Now this stoichiometric coefficient comes here, okay, and this N2 multiply, it is always multiply, remember, multiply, divided by H2, and this comes here, this coefficient comes here, and this, of course, if nothing is written, then it is 1 and 1, you don't need to write it. Okay, so this is the Kc, how we calculate the Kc. Now the only thing which changes the Kc is the temperature, and they are saying that without changing the equilibrium constant. Kc is temperature dependent, okay. So you can exclude this one because they are saying that which change will increase without changing the equilibrium constant, so we don't need this to be changed, and this only changes with changing the temperature, so we don't need to change the temperature. Now the next of adding a catalyst, no, this one is also wrong because uh, as I told you before, adding a catalyst speeds the rate of reaction, but it has no effect on the yield of reaction. It will not favor the right reaction or the left reaction. Uh, it will just increase the rate of reaction. Okay, decrease in pressure. Now, if we decrease the pressure, so let me just make this clear. So you must remember how many moles of gases are there. The pressure is, when we talk about pressure, only in the case of gases, and we can see all of these are gases. So how many moles of gases are on the left hand side and on the right hand side? Now, on the left hand side we have one mole of N2 and 3 moles of H2. So in total 4 moles of gas, okay, of gas, and on the right hand side we have 2 moles of gas. Now if we decrease the pressure, if we decrease the pressure, then the reaction will try to increase it. Okay, the reaction will try to, if we do decrease it, the reaction will do the opposite, it will try to increase it. This is the Lee-Chatelier principle. Okay, so we learn this PV is equal to nRT. Okay, where n here stands in the number of moles. Okay, now number of moles, it is directly proportional to the pressure. So more moles we have of a gas, the more the pressure will be. So here on this side it's like 4 moles, so here we have more pressure. Okay, and here we have less pressure. If we decrease the pressure, the reaction will go in the direction of uh, this side because it needs to increase the pressure. And as I told you that the more the moles, the more the pressure will be. So it will go on this side, and this will actually decrease the equilibrium concentration of NH3 because this reaction will be favoring the backward side, and then increasing the partial pressure of H2. Now, if we increase the partial pressure of H2, the reaction will do the opposite, like it will try to decrease the partial pressure of H2. How it will do that is to make more of this. It will make more of this in order to decrease the partial pressure of H2. So D would be the correct answer. So I hope that you understood all of the MCQs and their explanation. Uh, in any, if you still don't understand anything, just let me know and I will help you. Have a good day.